Today we're diving into a landmark paper, one that tackles maybe the biggest question in AI. How do you take something that's just unbelievably powerful and make sure it's also safe? How do you teach it to be helpful without ever being harmful? And really, it all comes down to this single question. It's one thing to build an AI that can write an essay or, spit out code, but how do you actually teach it our values? How do you make sure it's helpful, but, not harmful? So here's how we're going to break this all down. First, we'll look at the untrained AI problem. Then we'll get into how you can actually teach an AI human values. We'll walk through the exact three-step process they used, check out if it actually worked, and finally talk about why this is so important for the tech you use every single day. All right, let's jump right in. Section 1. We're talking about the core problem here. What happens when you have an AI that's brilliant, but completely unpredictable?
So just think about this for a second. These big language models, they're trained on, well, pretty much the entire internet. They're amazing at picking up grammar, facts, different writing styles. But what they don't pick up is a moral compass. They have zero built-in sense of what a person actually finds helpful or what's harmful. So one minute they could give you great advice, and the next, total nonsense. Or even worse, something actively dangerous. And this slide right here, it really shows you the problem in black and white. So on the left, you got a response to a question about fracking from a basic model. Look at it. It's vague, it's not helpful. It's basically a digital shrug. But now look at the right. That's from an AI that's been trained. It's detailed, it's balanced, it even gets the nuance of the controversy. That jump in quality is exactly what this is all about. Okay, so how do you get from that useless answer on the left to that really helpful one on the right? Well, the solution is actually kind of elegant, and it all comes down to something surprisingly human. You just ask people what they like better. And this brings us to the absolute star of the show, a technique called reinforcement learning from human feedback. You've probably seen the acronym RLHF. This is the groundbreaking method from this research, and believe me, it has completely changed the game for how things like AI assistants are built. So, what in the world is RLHF? Okay, the best analogy is this. Think about training a puppy. You don't hand it a rule book, right? No, you reward it when it does something good. That's exactly what RLHF does, but for a massive AI. It takes thousands, even millions of little human judgments, this answer is better than that one, and uses them as rewards to steer the AI in the right direction. Okay, but how does this actually work in the real world? It's not magic, it's a super clever three-step process. So let's get into the recipe for building a better AI. All right, so here's the high-level view. First, you collect a ton of feedback from actual humans. Second, you use all that feedback to train a whole separate AI model, which basically acts like an automated judge of what's good. And third, you use that judge to fine-tune the main AI over and over at a massive scale. We're going to walk through each one. Okay, wow, so this is the whole shebang, the full process laid out. I know, it looks a little complicated, but trust me, we're going to break it down piece by piece. Just to get our bearings here. Everything kicks off on the right with humans giving feedback. That data then flows to the middle to train what's called a preference model. Then that model is used to tune the final AI over on the left. So let's zoom in on that very first step. So here it is, step 1. This is literally the screen a human labeler looks at all day. They get a prompt and then they see two different AI-generated answers, A and B. Their job is super simple, but so important. Just pick the better one. Which one is more hopeful? More accurate, safer. It's that simple choice, but when you multiply it by millions of times, well, that becomes the fuel for this entire engine. Okay, now for step 2. This is where all that human data gets put to work. You take those millions of A or B choices and use them to train a totally separate AI. We call this the preference model, or PM. And its only job is to learn to think like a human judge. It's trained to predict which answer a person would prefer. It's basically learning our collective taste for what makes a good answer. And this is where the magic happens. Step 3. That preference model we just trained, it now becomes an automated judge working 24/7. The main AI generates a response, the judge instantly gives it a score based on what a human would likely prefer. And that score, that's the reward. This creates a powerful feedback loop that constantly pushes the main AI to get better and better at writing stuff that we humans actually want to read. Okay, so that's the process. But the big question, the million-dollar question is, did it actually work? After all that effort, all that data,
all that training, did the AI really get any better? And the answer is a resounding yes. The results are, well, they're pretty staggering. Just look at this chart. See that blue line kind of hugging the bottom? That's the original untrained AI. Now look at the orange and green lines way up top. Those are the models trained with RLHF. It's not even close. They score way, way higher on both helpfulness and harmlessness. The data is crystal clear. This thing absolutely worked. And let's go back to that fracking example just one more time to really see the difference. This is the ultimate before and after shot. On the left, you've got that weak, untrained response. And on the right, that's the final product after all this RLHF training. It's comprehensive, it's neutral, it's genuinely informative. It's exactly the kind of response that the human reviewers were giving a thumbs up to. But here's where it gets really interesting. The researchers found a fascinating little wrinkle in all of this. There's this constant push and pull, a tension between being helpful and being harmless. And it turns out it's really, really hard to be perfect at both at the same time. And this chart here really illustrates that trade-off. See, if you crank the harmlessness dial all the way up, the AI gets super cautious. It might even refuse to answer totally normal questions. But if you crank the helpfulness dial to the max, it might start ignoring important safety rules. So, finding that sweet spot, that perfect balance right in the middle, that's one of the biggest challenges in the field right now. So, okay, this has been a deep dive into a pretty technical research paper. But why does any of this matter to you? Well, because this technique isn't just theoretical anymore. It went from the lab to, quite literally, the phone in your pocket. Seriously, this isn't just some abstract theory. RLHF is absolutely everywhere now. It's the core engine behind pretty much any AI chat assistant you've ever used. That chatbot that answers your customer service question, the search engine that gives you a neat summary, even the tool that helps you draft an email, the reason they feel so helpful and, well, so human-like is because of this exact method. At the end of the day, what this research gave us is just enormous. It's a powerful, practical, and scalable blueprint for how to make AI systems safer and more aligned with what we actually want them to do. It's truly a cornerstone for building AI that's not just powerful, but also beneficial. And all of this leaves us with one last really big question. This entire system, this amazing technique, is built on a foundation of human preference. But that begs the question, whose preference? Which cultures? Which set of values gets to decide what good looks like for an AI that's used by billions of people all over the world? As this technology becomes more and more a part of our daily lives, that isn't just a technical question anymore. It's a challenge for all of us.